Hey guys, so I wanted to take time to go over some of the notes that we've done the past few days. So this is on the very first sheet that we got talking about linear inequalities. So this is taking it back just a little bit. So the definition we're given is an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. Each point in the region is a solution of the inequality. Well, we took time at the beginning to kind of dive into what this really meant. So the definition we came up with was a line that is either solid or dashed, you can say dotted if you would like, that creates a region of solutions. So let's look at what that means in the inequality, and then we'll look at a graph. So we're given this inequality, y is greater than x minus 3. So we're going to plug in the value 1 for x and 2 for y. So we've got 2 instead of y is greater than 1 instead of x minus 3. So we're going to simplify or solve. So we've got 2 is greater than 1 minus 3, which is negative 2. Well, is 2 greater than negative 2? Yes. So if this statement is true, then the original ordered pair 1, 2 is a solution. So the answer is yes. Now we go into an example that is not a solution. So we're plugging in negative 3 for x and negative 7 for y. So we have negative 7 is greater than negative 3 minus 3. So if we simplify, negative 7 is greater than negative 6. Well, negative 7 is not greater than negative 6. So this is not true, and it does not create a true statement, so the answer is no, it's not a solution. To quicken this video just a little bit, this part A through E is just looking at the ordered pair. So the first one is 4, 5. So there's your x, there's your y value. You're going to your graph. This inequality line is giving you this whole region of solutions. All of the shaded area are solutions. So 4, 5. Let's go in there just a little bit. Start at the origin, go over to 4, up to 5. So that point right there. Is it in the shaded area? Yes. So it is a solution. Now I'm going to skip to 4, negative 2. So there's your x value, there's your y value. So start at the origin, go over to 4 like we did earlier, and down to negative 2. So if we have a solid line, so solid line, there are going to be solutions on the line. So only because the line that was given is solid, 4, negative 2 is a solution. Now what if it was dashed? What if it looked like this? So this would be what a dashed or dotted line would look like. There are not solutions on the line. So what does this look like? How do we know if it's dashed or dotted if we are given an equation and we are asked to graph it? Well, if we have the inequality less than, then we're going to have a dashed. The only reason why we know it's dashed is because there's not an or equal to. So the less than is dashed, and we've got less than, so we're going to shade up below it. So we're going to shade below. Now, greater than is represented by the symbol right here. It also doesn't have a or equal to part, so we're going to have a dashed line. And because it's greater than, it's going to be above. Now, because we have or equal to on the third one, we've got less than still, but then we've got a little line underneath saying or equal to. The or equal to is telling us that it's a solid line, but we are still shading underneath the line because it's less than. Similar, greater than or equal to, still going to have a greater than sign, but the or equal to is going to create that line underneath. We're going to have a solid line to represent or equal to, and then we're going to shade above because it's greater than. All of our solutions are greater than the equation. So what does this look like? So we're going to graph this equation as if it was a y equals x minus 2. So our y-intercept is -2, and our slope is +1. Now, a whole number doesn't really tell us how to move on the graph when we're talking about slope. So we're going to create a fraction by putting a +1 underneath, because 1 divided by 1 is still 1. This +1 in the numerator is going to tell us to go up 1, and the +1 in the denominator is going to tell us to go to the right 1. So we're going to graph this, starting at the origin. Y-intercept is -2, and our slope tells us to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, or we could go backwards and go down 1 to the left 1, down 1 to the left 1. So this is what our graph would look like. Now, do we have a solid or dashed line? Is there a line underneath the inequality sign or symbol? No, there is not. So it's going to be dashed. Now, is it less than or greater than? It's greater than. So it's going to be above, just like we have up top or in the middle of the page. So we're going to shade above the line. So this is what our graph would look like. Now, again, the point of this graph is to show that all of the possible solutions are in this shaded region. So I could choose a random point in the region, so -1, +1, right there. It is a solution if we wanted to figure that out. So now I'm going to skip over a little bit to this one. So if we wanted to graph this one, to graph, you may want to take time to think about it being just x minus 1 to try to visualize what the line would be if it wasn't an inequality. So x is -1. Go over to the left 1 for x. Now it's going to be a vertical line because what it's representing is that it doesn't matter what the y value is, x is always constantly on this line -1. So we're looking at the vertical line that goes through x equals -1. Now, is it going to be dashed or dotted? Is there a or equal to sign or a part of the inequality? No, so it's going to be dashed. So you're going to have a dash line. And then is it greater than or less than? It is greater than. So all of our x values, according to the inequality, is going to be greater than -1. So we want the values of x that are greater than -1, which is on the right side versus the left side. Then we're going to skip to the very bottom because this one's a little bit difficult. So you start with x. I've got to change colors. Is this better? Yep. So you start with x minus y is greater than or equal to -3. We want y by itself because we always want it in slope-intercept form. So we're going to subtract x, x minus x cancels out, and we're left with -y is greater than or equal to -x minus 3. We're still not done. Y is still negative. We want it positive. Slope-intercept involves a positive y, not a negative. So we know that there's an understood 1 here, so we can divide by -1, divide by -1. -1 divided by -1 is positive, so it cancels out. So we're left with y is greater than or equal to -1 divided by -1 is positive, so we're left with x. And -3 divided by -1 is +3. Now most of you think, oh, well, we're done. We've got y by itself. We're good. No, we would be done if it was equal to, but it's not equal to, it's an inequality. So we have to ask ourselves, did we multiply or divide Did we multiply or divide while we were getting y by itself or while we were getting the inequality in slope-intercept form? Yes. If we say yes, that should be a comma, did we do it by a negative? Yes, we divided by -1 right there. So, yes, we did. If yes for both, then flip the sign. So what we're flipping is, instead of y is greater than or equal to x plus 3, now it will be y is less than or equal to x plus 3. So you have to flip it if you do a multiplication or division by negative. So now we're going to graph this. Our y-intercept is positive 3, and our slope is positive 1. We're going to make it a fraction by putting a positive 1 underneath. So we're going to go up 1 to the right 1. So starting at our y-intercept, which is positive 3. So here's our positive 3. And we're going to go up 1 to the right 1. Up 1 to the right 1. And then we can go the opposite way by going down 1 to the left 1. Now looking at the equation or the inequality that we got after flipping it, we've got to determine, is it going to be a solid or dashed line? It's going to be solid because it has the or equal to part. So here's our solid line. Then we've got to determine, is it less than or greater than? It is less than. So it's going to be shaded underneath the line. So that would be our inequality graphed completely. Remember to pause the video if I am going too fast for you to copy it down. So then we moved on to graphing systems of inequalities. So I included kind of a little cheat sheet. So remember, it's a solid line if it has the or equal to part. Doesn't matter if it's less than or greater than, as long as it has the or equal to, it's a solid line. Now, if it does not have the or equal to, it is dotted or dashed. The other cheat sheet is whether you shade above or below. This part that says only if y is positive, if we have y equals mx plus b, because all of our inequalities should be in slope-intercept form, our y is going to be positive. We cannot have a negative y. So all of our greater than inequalities are going to be above, and all of our less than inequalities are going to be below. So let's do one. Let's skip down to number 4, just because I know a lot of you are going to struggle with the first one. So the first one, again, if you need to, act as if it's x equals 5. So I'm going to go on the x-axis, which is the horizontal one. Y is the vertical. I'm going to go to positive 5, starting at the origin. 1, 2, 3, 4, 5. And it's going to be a vertical line because it's saying that does not matter what the y value is, x is always 5. It's going to be dashed because we don't have the or equal to part of it, because there's not a line underneath the less than sign. Then we have to determine if we shade the right to the left because it's a vertical line. It's less than, so what it's asking us is to show all of our solutions for x and y are going to be less than x equals 5. So all of these values to the left are x values that are less than 5. That is why we shade on the left side. So we have a dashed line and shading to the left for the first one. Now, it wouldn't be a system of inequalities if we didn't have a two to graph. So the second one is already in a slope-intercept form. So we've got a y-intercept of positive 2, and then we have a slope of positive 1. Again, we're going to create a fraction out of it and put a positive 1 underneath, and we're going to go up 1 to the right 1. Now we're going to graph it. Starting at our y-intercept, here's our origin. We're going to go up 2, and there's our y-intercept. And I'm going to make it pretty big so we can see it through that blue. Then we're going to go up 1 to the right 1, up 1 to the right 1. Or we could go the opposite way, down 1 to the left 1, down 1 to the left 1. Now, is it going to be dashed or solid? It's going to be solid. We do have a or equal to part of the inequality. So we are going to have a solid line through those points. And everybody knows I can't draw a straight line to save my life in real life, so definitely not on a screen. Now, is the sign, is the inequality symbol less than or greater than? It is less than, so it's going to be beneath the line. So all of the values or all of the ordered pairs beneath that green line is a solution to just that inequality. Now, looking at this, it may be a little bit confusing, a little bit messy for some of you, but we want to look at just the region that the two inequalities overlap. That is going to create our region of solutions for both inequalities. So this region right here are all of the possible solutions. So if you want to have a third color to shade all of that in, that's fine. Honestly, in my opinion, it makes it look a little bit even more messier. That's up to you. So I wanted to show you exactly what we did in class. This is just a simple picture of what we did. I wanted to give you a chance to copy this down. So if we had, let me get my pencil. If it was x equals 2, we would start at x equals 2, or the ordered pair 2, 0, and then we would have a vertical line. So if x equals something without an x or a y on the other side of the inequality or equal sign, it's going to be a vertical line. Now, if we look at the second inequality and we said, oh, well, y equals -1, we can graph that line before we worry about the inequality part. We go on the y-axis, which is right here. So we go to -1, which is that big dot. And we have a horizontal line through that point. So if we have y equals something without an x on the other side, it's going to be a horizontal line. I also wanted to take time to look at possible solutions within that overlapping region that we did for number 4. So if we took -2, 0, so starting at the origin, going over to -2, which is right there, it is on a solid line, which is from the second inequality. Because it's on a solid line, it is a possible solution. Now, what if we went to 5, 0, which is right here? That is on the first inequality. It's on a dashed line, so it is not a possible solution. So remember, as you're watching the videos that I do post, this is not for you to learn from the videos, but rather you use it as a study guide or a study tool to prepare for the assessment. It's also a way for the people that are out constantly to use this to catch up, especially without comment time.